You must know the equation of a circle. This is analytical geometry. Please subscribe. Okay, we have the standard equation or the standard form of a circle that you must know, which is open bracket x minus a close bracket squared plus open bracket y minus b close bracket squared equals r squared. So this is the equation of a circle or the standard equation of a circle. So a is the x coordinate of the circle center. B is the y coordinate, since it is inside the bracket with the y value or y alphabet, so it is the y coordinate of the circle center. Then for you to have the coordinates of the circle, you just take a and b to be in one bracket as the form of a coordinate. Then r is the length of the circle's center. R is the length of the circle center. Then if the circle is at the origin, so it will have Pythagoras of theorem as the equation of a circle. Only if the circle is at the origin. Remember the origin from the Cartesian plane or on the Cartesian plane. So this is very, very important, guys. You must know this. And you must know the introduction of Euclidean geometry of what the radius and the diameter is. Then let's say determine, because they can actually give you an equation of a circle, then they want you to determine the coordinate of the center as well as the length of the radius. So here determine the coordinates of the center and the length of the radius. Remember, a radius is a line that is drawn from the center to a circumference. Please watch Euclidean geometry in our channel. So let's say we have x plus 9 squared plus y minus 3 squared equal to 100. So as you can see that 9 here is a and 3 is b, then this 100 it is r squared. Then they want us to take whatever that's inside the bracket, to equate it to 0, then you solve for x. So x becomes negative 9, then y minus 3 equals 0 equal to positive 3. Therefore the coordinates of the center now is negative 9 is to positive 3. Then as you can see, this 100 here, it is r squared, and they want us to find r, meaning you'll say r squared, then you square root both sides, going to have r as 10 units. So it is in units because it is r, but as it was r squared, they will never write any unit beside whatever number that they're saying that r squared is equal to or the radius is equal to. So if they put units, for example, let's say they say the length of the radius is 200, that's 200, it means it is r squared. But if they say it is 200 units, it means that r squared, that radius is r. I'm not sure if you understood that, but if you didn't, please just rewind the video and try to listen what I said. So if you have x squared plus y squared, then saying it is equal to 36, it means that the circle here, it is at the origin, or it is on the origin. Why? Because we're having Pythagoras of, theorem of Pythagoras. So this is what I was explaining up there. Okay, so they want us to write the coordinates of the center, so it will be 0 is to 0 because it is on the origin, or z the origin. So arc squared equals 36. You say it is 36 there because we are actually square rooting, looking or determining the value of r. Why? Because that 36 is not written units, meaning it is still r squared, not r. So it becomes r whenever it is written units. So if they said 36 units, it means that will be r, not r squared. But I hope you are actually getting the gist of what I'm saying here. This is very, very important. Okay, we'll try to continue. So let's say we are actually given, they want us to write the coordinate of this circle, x minus 3 squared plus y plus 2 squared equals 9. They want us to write the coordinates of the center. Therefore, you take whatever that's inside the bracket, you equate it to 0, then you solve for x, then you got x as positive 3, y equals negative 2. Then the center is 3 is to negative 2, then r is 3. I square rooted both sides for me to get r3. So this is the circle center and the radius. So you must know that sometimes you'll be asked to find the coordinates of the center while the circle is not in its standard form, meaning you have to do it to complete the square. That's very, very important for you to know. So if it is not in its standard form, the circle is not in its standard form, you complete the square. Okay. Suppose you are actually given okay, I'm just thinking of the right one that we can use. Okay, we have x squared plus y squared minus 6y minus 55 equals 0. You see that this is not in a standard form, meaning you must complete a square. Okay, so as you can see, x squared, we do not have the coefficient of x, we only have the coefficient of x squared. So we just write it as it is. It means the coordinate there will be 0, so plus y squared minus 6y. Then before we can complete a square, we just actually transpose the 55 to be on the right, so that on the left we are left with x and y. Then this is what you must know: half times it can be coefficient of x or it can be the coefficient of y. But now here, since we do not have the coefficient of x, we would actually use the coefficient of y, meaning half times coefficient of y, that's negative 6. You take it with its sign, then close the bracket, square, then you work out everything that is inside the brackets before using that exponent. You do not use your calculator. Use your calculator only whenever there's nothing that you can do anymore inside the brackets. So we can actually simplify this further. It will give us positive 9. Then that positive 9, you will actually add it and subtract it, then equal to 55. So we cannot actually use half times quotient of x because we don't have the quotient of x. Therefore, we're going to use, we're going to say x squared plus, you take that step before the answer with its brackets, that negative. Okay, let me just try to fix it here. So plus y, then you take whatever that you have before the answer, that negative 3 squared minus 9 equals 55. So that's very, very important, guys. You need that step before the answer. So you transpose the 9 to the right, you have x squared plus y minus 3 squared equal to, you use your calculator, do not make yourself a staring, so you're going to have 64. So the equation now, it is in its standard form. But as you can see that x here, or x squared, it is actually, it's going to give us 0 as our x coordinate of the circle center. So what we're going to do now is 0 is 2, positive 3, and this is the circle center. Then what about our r? So r squared equals 64. Why? Because this is not written units. So we square both sides. Then we have r as, is it 8? Yes, it's 8 units. We're writing units because now it is no longer r squared, it's r. I hope you guys are understanding this. So they can give you something like this since it is not in its standard form. So this is the standard form. So since if it is not in a standard form, what you must do is that you complete the square. I hope you are getting what I am saying here. So this is very important. They can give you a circle while it is in its standard form. Then it's actually simple for you to find the circle center and as well as the length of the radius. Or they can give you in the circle as it, maybe the circle is in origin or at the origin, or they can give you a circle, the coordinates, not actually the coordinate, the equation where the circle is not in its standard form. Then you must do what? You must complete the square as I was doing here. Okay, I think we can move forward. Okay, we have x squared plus 2x. We are grouping the like terms, plus y squared plus 4y. You see now that we can actually use the coefficient of x multiplied by 1 because we do have it, right? We do have the coefficient of x. The 4 aside, we write half times coefficient of x. This is a way of completing the square. We have 2, then we work out whatever that's inside the bracket. We have 2 over 2 exponent 2, then inside the bracket we have 1 squared, then the answer is 1. Then we're going to take that 1 and add it and subtract it, plus y squared plus 4y. Then we say half times coefficient of y, which is 4, exponent 2. Then we divide by 1 so that we can deal with fractions both sides. 4 over 2 squared, then inside the bracket we're going to have 2 to the power 2, which is 4. Then that 4 we're going to add it and subtract it, equal to 11. Then as you can see, we have the first trinomial here and the second trinomial. Therefore we write x, then you go there before the answer, you take whatever step that you have there. It is x plus 1 squared, then plus y. Before the last step, you're going to take that 2 with its exponent 2, plus 2 exponent 2, then equal to 11. Then that negative 1 and the negative 4, you add them, you're going to have negative 5. Then when you jump the equal sign, it will be positive 5. Therefore x plus 1 squared plus y plus 2 squared equals 16. Now you can see that now the equation of the circle is in its standard form. Then you can actually write down the coordinates of the center as well as the radius or the length of the radius. R squared equals 16. For r now equals what? Equals 4 units. Why? Because it is r, not r squared. I hope now you're getting the gist of r squared issue and r. Very, very important. So this is, you only do this if you are given the equation of a circle when it is not in its standard form. Then you complete the square. Let's try to do this question. They say write down the equation of the circle with center at the origin and radius of 20 units. So that's not r squared, it's just r because there are units. So when they talk about the origin, you know the coordinate is 0 is to 0, and the radius here, since you see units, it means that's r, not r squared. Okay, so let's try to write down the equation of the circle with that information that we are given in option A. So it is x squared plus it's x squared plus y squared, because this is in the origin, or is it the origin? And this is not r squared, it's just r equals 20. Therefore 20 times 20, you're going to have what? 400 there. So this is the equation of the circle, right? Then B, they want us to find the circle, the center, the equation of the circle if the center is 3 is to negative 7, meaning it will be x minus 3 squared plus y plus 7. Okay, y plus 7 squared, and the radius is 10 units, so r squared will be 100. So this is the equation of the circle. So you can see all of these things, or all of these answers are in their standard form. So we are happy. I hope you are getting this, guys. I think you can try to move now and continue to do other things. Here they want us to determine the value or values of a if a equal to, if a negative 3 is to a, then meaning we're going to take that point and substitute it on our equation. So that's x and y there. That negative 3 is x, a is y. Meaning that we're going to substitute them like we're doing in algebra simultaneous equations. So we're going to take that negative 3, where there's x, we put negative 3 squared, where there's y, we put a. Then squared equal to 13. Therefore, we have 9 plus a squared equals 13. Therefore, a squared equal to 13 minus 9. That's 4. Then you square both sides. You square root both sides, and you're going to have it's plus or minus a equal to 2 or a equals negative 2. So you leave it like this because the question, the statement said determine the value or values. So it might happen that we have two values, the value of a as a positive value and the value of a as a negative value. Actually, I wanted you to do this one on your own, but I will actually do it maybe after this one. I'll give you yours if possible. Okay, then they want us to find the equation of the circle with center, that's the center, passing through the point. So I think what we can do now, we can actually write the equation of the circle, because that's what the question is saying. Find the equation of the circle with center. Just that we're not given what the radius, but we'll see. Then plus y plus 1 equal to r squared. Then what we're going to do now, we're going to take that point 2 is to 5 and try to substitute it on what we are having, so that we can find the value of r squared. So that's the purpose of us actually substituting that point. So you take it and substitute it on the first bracket and on the second bracket where there's y. Remember, 2 is x and 5 is y, meaning where there's x, you're going to substitute 2. Where there's y, you're going to substitute 5. So 2 minus 1 squared plus y, it is negative 5 equals r squared. Therefore, inside the bracket, we're going to have 1 squared plus negative 4 squared equals r squared. We have 1 plus 16 equals r squared. Therefore, 17 equals r squared. We take it and substitute it on that equation. Therefore, x minus 1. We will never actually square root them. Why? Because we're looking for r squared and 17 is r squared. Therefore, y plus 1 squared equals 17. So that's what we are having as the equation of the circle with that given sensor and passing through that point. So you just have to take the point and substitute it on that equation of a sensor and find r squared. So what you must know, there's something known or something called intersection of circles, meaning circles can intersect, meaning they can give you two circles, then they ask you if the circles are intersecting or not. So it's very important for you to know this. So let me just draw three scenarios where we are having our circles intersecting one another or each other. Trying to draw the second one over here. Okay. Then second option, just want to talk about them at once and explain each of them. Okay. And the last one, I'll actually draw it down here. Please like the video. Please like the video, guys, and do not forget to hit on the notification bell so that you can be notified when we upload new lessons. Okay, so let me try to erase these parts here. Okay, now let's say this is option A, this is option B, and this is option C. Okay, we have, let me indicate the radius, line drawn from the center to the radius. So this is the center, but let us make it a little bit short. So this is the center, and that white line you see on your screen is the radius. Let me use another color to draw the radius of the other circle. So this is the center over here, and this is the radius. This is also the radius of the second circle. In option B, let me do the same thing with these ones here. This is the radius, and this is also the radius. Okay, this is R2, and this is R1. This is R1. This is R2. This is R1 and this is R2. So R1 is radius 1 or face radius, and the second radius is R2. Okay, so let's talk about option A. Center, we have the coordinates of the centers. These are coordinates. You'll be given their equations. Then you write them. So let's actually talk about them, then we move or we continue. So here you're going to use the coordinates and find the distance using the distance formula from Analytical Geometry of Grade 10. Then if that distance is less than the sum of R1 and R2, it means that the circle or the circles are intersecting at 2 points. So you're going to use the distance formula. You use your sensors to find the distance using the coordinates of the sensors. Then when you compare them with R1 plus R2, their radius, if D is less than R1 and R2, it means that the circles are intersecting at 2 points. As you can see that they are intersecting at 2 points. Then option B, I'm going to write it over here. So you're going to find the distance. Then if the distance is equal to the sum of R1 and R2, it means that the circle or the circles, they do not intersect, as you can see, but they touch or they are touching, right? You use the coordinates of the center to find the distance of the circles. So they do not intersect, they only touch, as you can see over here. So this is their point of intersection. Then you're going to take those coordinates of the sensor. You use the distance formula from grade 11, I think from grade 10 if I'm not mistaken. Okay, so this is the formula that you're going to use. This formula over here you're going to use. You find the distance between the centers, then you compare them with the sum of the radii. Then if that distance is equal to R1 and R2, it means that they do not intersect but they touch. I hope you understand what I'm saying here, guys. Then option number 3 or C. So D here will be greater than R1 and R2. As you can see, the circles, they are not touching. So you're going to use those coordinates of the center. You find their distance using the distance formula. So what you must know here, when the distance is greater than the sum of R1 and R2, is that the circles are not, or they do not intersect. So that's very, very important, guys, for you to know. They do not intersect. Why? Because the distance between the centers is greater than the sum of the radii. So radii, remember, is the plural form of radius. I hope you know that. You watched our video on Euclidean geometry. If you didn't watch it, please make sure that you do watch that grade 11 Euclidean geometry, circle geometry. Very, very important. And please like the video if you do understand what we are doing here as Maths and Science series. And another thing, we are based in Phosphorus, offering Saturday classes and Sunday classes in Phosphorus. And we do have a program for those that are upgrading their results in Phosphorus from Monday to Friday. Then grade 10s to grade 12s, we are having Saturday classes. We're trying to write the solutions here. They want us to find what the centers and the length, the radius of the circles. So we are given the equation of the circle in the origin. So the coordinates of the center will be 0 is to 0. This is the center of the circle, and the radius, it is r squared equals 4. Therefore, let us find the value of r. We know that r is 2 units, that's the radius. Therefore, on the other circle, we are given the equation of the circle, and we know that this is the equation of the circle. It's in its standard form. Therefore, the center will be 2 is to negative 3. This is the center of the second circle. then r squared equals r, so that we can find the radius. R squared equals 9. This is 9 here. We determine the value of r to be 3 units, and we know that this is the radius. So we are done with that. Then they say whether or not the circles intersect. Remember, we have 3 options. For us to do that, we have to use this center and the second center here to find their distance. Therefore, distance x1 minus x2 squared plus y1. Use the analytical formula for us to find the distance. So distance, let us actually say that this is x1, y1, then this is x2, y2. Therefore, x1 is 0 minus x2, which is 2 squared, plus what is y1? It is 0 minus 3, which will give us positive 3. So you must show the substitution. So here, when you punch this in your calculator, you're going to have, okay, let me punch it in my calculator. We're going to have square root 13. Then when we write it in decimal form, we know that this is 3.6 units. Therefore, we need the distance and the r. We can add the radii of the 2 circles, 2 units and the 3 units. So 2 plus 3, we're going to have 5 units. So you need to compare the distance with the radius, or the radii, the sum of the 2 radii. So as you can see here that we have 3 options. Let me just write them down. The second one, d is greater than r1 plus r2. Then d is less than r1. Sorry, it's not d. So d is less than the sum of radius 1 and radius 2. Therefore, these are the 3 options that we're having for us to conclude or to answer that question. So we know that d is less than r1 and r2. Therefore, what we can say is that these 2 circles that we are given, for us to answer that question, we can say that circles do not intersect. Why? Because the distance is less than the sum of the radii. So this is how you answer these types of questions. So make sure that you use your past papers or whatever thing that you'll be using in order for you to answer these types of questions. So this is very, very important. So if you didn't understand it, make sure that you understand when I was explaining those 3 options, where on that part of the intersections of circles. So please make sure that you understand that before you can actually try to write down or answer this question. What we have now, let's say, okay, let's talk about the tangents of the tangent to the circle, or tangents to circles. All right. This is the circle. Remember, we find tangents to curve, or tangent in a curve or in a function. So we know that this is the radius, a line drawn from the center to the circumference. Let's name it center O. Then let me take out my ruler, just trying to draw the tangent. The tangent. Okay, I think it is adjusted now. Okay, let me draw the straight line using the white pen. Okay, let me use the pink pen. Okay. So this is our tangent. So that pink color or that pink line that you see, that's a tangent. Now we can say that, let's say we have 90 angle of 90 degrees there, and we can actually name our tangent. Here, this is the radius, as we know that the line drawn from the center to a circumference, the radius. Then this is the tangent. Why? Because it touches the graph at one point. So that's why we're calling it a tangent. We have tangent AC. So it is the tangent at point B, where it is 90. So what you must know about point B is that point B, it is the point of contact, or it is the point of tangency, where the line touches what, the circle at one point. So that B is the point of contact, will be given its coordinate, and the graph or the tangent is represented by a linear function or a linear formula, which is y equals mx plus c, or even y equals ax plus q, where m is the gradient, but the gradient of what, of the tangent, and c, it is the y-intercept when we talk about linear functions. So this is, you will be given the center. You will use the center as well as the coordinates that will be given in the point of contact B. Then you use those two coordinates to find the distance. To find the radius, the gradient or the radius. Okay, there are steps that we actually use for finding the equation of the tangent. So make sure that you pay attention here, because this is where many learners are actually getting this wrong. So there are 3 steps that we're going to talk about. The step number 1 for finding the equation of the tangent, you must find the gradient of the tangent. That's the first step. Find the gradient of the tangent at a given point of tangency. Number 2, you find the gradient of the tangent using the gradient of the radius. Actually, that first step, I was supposed to say find the gradient of the radius, but I'll fix it right now. So there's a property that you use to find what, the gradient of the tangent, using what, the gradient of the radius, which is the first step. It is m radius, or the gradient of the radius times the gradient of tangent, equal to -1. When you multiply them, they must give you -1, meaning that m radius is perpendicular to m tangent. Then when you multiply their gradients, they must give you -1. It must give you -1. So what we have here, first step, you find the gradient of the radius, not the gradient of the tangent. So the gradient of the tangent is the second step. So for you to be able to determine the equation of a tangent, you must understand these 3 steps that I'm going to actually write or talk about here. So m radius, the radius that you calculated, there's the radius that you're going to use in order for you to find m tangent. So this is the formula that you use to find m tangent. Remember, because the y equals mx plus c, where there's m, you know that is what, the gradient, but you use the gradient of the tangent, not the gradient of the radius. But we'll make an example. So use the given point, the third step. Use the given point of tangency, or point of contact, and the gradient of the tangent to find the equation of the tangent. But we'll make an example so that you can understand this. So this is the formula that you use in order for you to write what? The equation of the tangent under analytical geometry. So you use the center and the point of contact to find the gradient of the radius. Then after finding the gradient of the radius, you use them to find what? The tangent, or the gradient of the tangent, because y equals mx, that m there, the gradient, is not the gradient of the radius, but you put or you substitute where there's m, the gradient of the tangent that you're going to use using that that you're going to find using that property that says m radius times m tangent equals -1. So if you have m tangent, you can make if you have m radius, you can make the m tangent to be the subject of the formula. Then you can use that m tangent as the gradient of the tangent. Then you use the point of contact, you substitute it where you substituted the m tangent. Therefore, you will have y equals the gradient that will be having an m tangent plus c. Then you use the point of contact to find c. Okay, so here they want us to determine the equation of the tangent to the circle x squared plus y squared equals 8 at the point a 2 is to -2. So here we must find what? The center of the circle. They want us to find the tangent. So the most important thing is for us to find the center and that point. So we know that the center here must be 0 is to 0. Why? Because the circle is at the origin. And we do have the point of tangency, which is 2 is to -2. So we use these coordinates to find m radius. We use them to find m radius. We use the gradient formula that you were taught in grade 10 and grade 11. So m radius equals that this is step number 1. Make sure that you follow those steps. y2 y1 minus y2 x1 minus x2. Therefore y1 it is 0 minus y2 it will be minus into -2. Substitution is very important. -2. Therefore use your calculator. You're going to have 0 plus 2 and -2, which is 2 over -2, that is -1. This is m radius. It is not the one that you're going to substitute on the formula of the tangent or on the gradient, but we must actually find m tangent in order for us to find the gradient of, the equation of the tangent. I hope you understand that. So step number 2. This is step number 1. We actually calculated m radius. So step number 2, m tangent times m tangent equal to -1. Sorry, it's m radius. It's m radius, not m tangent. So m, let me fix it here. M tangent times m radius. Therefore times m radius. M radius, it is that -1 equal to -1. Then you can make m tangent the subject of the formula by dividing both sides by -1. Now we have m tangent as +1. So this is actually the gradient that we must substitute on the formula of the straight line or the tangent. Very, very important. This is what we need to find the gradient, the equation of the tangent. Therefore, we're going to use the formula of the straight line function, of the linear function. So that's very, very important. Y equals mx plus c. So we do know the value of the gradient, which is 1. So we're going to say 1x or just x plus c. So for us to find the value of c here, what we must use is that point of contact, point A. Then we substitute it on what we have. -2 equals 1 or x. Okay, let's just put that 1. Where there's x, we put 2 plus c in order for us to solve for c. Then c minus 2, because 2 times 1, when we transpose it, will be -2. Therefore, c equals -4. Therefore, we take this c and substitute it back. So we have x minus 4. This is the equation of the tangent. So you must follow those three steps. You start by finding m radius using the point of contact and the center. Then you use m tangent times m radius equals -1 to find m tangent. Then that m tangent, you use it to find what? M radius times m tangent equals -1. You substitute the answer that you got when you were using step number 1. Then after that, you substitute m tangent on the formula. Then for you to find the for you to find the value of c, you must use the point of contact as I've done here. So please make sure that you follow those three rules. That's how you will only be able to determine what the equation of the tangent. So follow the rules. Maths actually, it's a subject of rules. If you do not follow the rules, everything that you are doing, it will be incorrect. So you must know all the rules. Very, very important. As you know that you won't go outside naked, so you have to wear. That's the rule. So if you don't know that, it means there's something wrong with you. So for you to be able to do this, make sure that you follow those three rules. Very, very important. So the rule for a cell phone, if the battery is flat, for it to function again, you have to charge it. That's the rule. If you don't charge it, it will never work. So same thing applies with mathematics. If you know the basics of mathematics, it will be simple for you to understand whatever that you are doing. So we follow the rules. We follow the rules. So here we are. Okay, they say find the equation of the tangent. So we know that the tangent is represented by y equals mx plus c. So the most important thing here is that m here, this is the gradient of the tangent, not just any gradient, but it is the gradient of the tangent. Meaning that we have to follow those steps. We have the center here, the coordinates of the center and the point of contact. So this is the center, 2 is to -1. And the point of contact we are having is 0 is to 3. So this is the point of contact or the point of tangency. Okay, so we're going to find m radius. That's the first step. Remember, m radius 3 minus into -1 over 0 minus 2. Then 3 plus 1 over -2. Therefore, the gradient of the radius, it will be -2. But for us to find m tangent, that's not the 2 that you're going to actually use the -2 and make it the gradient of the tangent. You use the property m tan times m radius equals -1. Then we do have the value of the m radius, which is -2. Then you equate it to -1, you divide both sides by -2 and make m tangent the subject of the equation or the subject of the formula, since you're solving for m tangent. Divide both sides by -2. Therefore, you're going to have m tangent as 1 over 2. Then this 1 over 2 here, it is the equation of, it is the gradient of the tangent. Therefore, y equals mx plus c. Where does m substitute? 1 over 2, not that -2, because that -2, it is the gradient of the radius. But we are asked to find the gradient of the tangent. Therefore, you use this point over here, not the center. You use the point of contact, the point of tangency, to find the value of c. So you substitute 3 where there's y. So it's going to be 3 equal to half into 0, because x is 0, plus c. Then let us make c the subject of the formula. It will be 3. Therefore, y equals half 1 over 2x plus 3. So this is the equation of the tangent. Follow those 3 steps. They are very, very important, guys. They are very important. So I'm not sure if you understood this part, but it's very important for you to understand it. You must follow those 3 rules. You first find the M radius, then for you to find M tangent, use that property, then use the point of tangency to find the value of C. So you'll do this one on your own, and please send your answer on the comment section, since this is the only question that I'm giving you to do on your own or by yourself. So do this one, and then we'll try to continue with with the next part. Okay, so there's this part that many people are not getting it right. So this is the part whereby you will be asked to prove if the point is lying on the circle or on the circumference, or the point is lying inside the circle, or the point is lying outside the circle. So for you to be able to do that, you will be given, or you must have what, the radius. You must have the radius, or you must have the value of the radius. Then you use the center with whatever point to find the distance using the distance formula. Then after that, you compare the radius and the distance. Okay, so as you can see here, they can say prove that the point lies in the circumference, on the circumference. When they say that, it's on the same thing as they prove that the point lies on the circle. So what you will do now, for an example, we have the center to that point on the circumference. Then they say prove this point lie on the circle or on the circumference. What you will do, you will find the distance between the point using the distance formula. Then you compare that distance with the radius. If it is equal, or if they are equal, it means that the point on the circumference lies on the circle or lies on the circumference. I'm not sure if you understand that. You use what, the distance, the center and the point. So if this point here, and okay, they want you to ask, they ask you that prove that this point lies outside the circle, you'll use that point and the center, then you find their distance. After finding their distance, you compare the distance that you will get with the radius. Then if the distance is greater than the radius, it means that that point lies outside the circle. I hope you guys are understanding this. This is a very, very important thing for you to know. Use the center as well as the point that they're asking you about to prove. So let's say use the center and the point that is inside the circle over here. So you'll use the coordinates of the center and the coordinate of the point. Then you find what? The distance. After finding the distance, you will compare the distance with the radius. So if radius is greater than the distance between the center and the point inside the circle, it means that that point lies inside. But this one over here lies outside because the radius is greater. The distance is greater than the radius. But this one here is on the circle. Why? Because the distance of the coordinates of the center as well as that point lies on the circle. Then this one lies inside the circle. Why? Because the distance is less than what? The radius. I'm not sure if you understand it, but let me try to simplify it further for you guys so that you can be able to understand. But this is very, very important. They want you to prove that a graph lies inside or outside. This is what you do. Use the center and the point. You determine the distance. Then you compare the distance of the center with whatever point that the question is asking you to prove. You find the distance, then you compare the distance with the radius. Then that is when you can actually conclude. I'm not sure if you understood that part, but if you didn't, please make sure that you rewind the video. Make sure that you understand it. Make sure that you understand it. Many learners are getting these types of questions. They're getting it wrong. So I'll try to do what I'll try to summarize it for you guys so that it can be much easier. So I repeat, you use the coordinate of the center as well as the coordinate of the point. You find the distance, then you compare the distance and the radius that you are given, the radius of the circle. Then that's when you will actually conclude that saying that it lies inside or it lies on the circumference. If they say it lies on the circumference, the same thing when they say it lies on the circle. That's very, very important. Now let me try to simplify it for you guys so that you will actually remember it easily. Okay, let me adjust my screen here. Okay, now if d is equal to r, if the distance is equal to r, it means that that point lies on the circle or lies on the circumference. It's either circle or circumference. But if d is greater than r, it means that the point lies outside the circle. Then if the third one, the first one, d equal to r, lies on the circle on the circumference, d greater than r lies outside. But if d is less than r, it means that the circle lies inside. The point lies inside the circle. That's very, very important, guys. I hope now this one makes a lot of sense. So you must make sure that you understand these three scenarios. Very, very important. These are the easy marks, or the marks that you must actually get when it comes to analytical geometry of this part. So we are given the center here, as we can see, center of the circle, and they said that VR is a tangent. So where's VR? Here's VR as I'm highlighting. Then alphabet L or angle L here, the alpha, it is equal to 80.54. So the first question, they want us to show that the equation of the circle is given by x squared plus y squared plus 6x minus 8y equals 0. But what we know is that we are given the center of the circle. Therefore, we can try to write it in its standard form. X plus 3, since 3 is negative there, plus y minus 4 squared equals r squared. But the problem, we do not have r squared. We can use the point K here. We would use L if we had the coordinates of L, but we use K because it is on the circumference, or it is on the circle. So we'll take that point and substitute it there. So x is 0 plus 3, y is 8 minus 4 squared equals r squared. We are actually determining the value of r squared. Therefore, here we have 9 plus 16, if I'm not mistaken, equals r squared. Therefore, r squared equals 25. Then we can take it and substitute it where there's r squared, meaning we have x plus 3, x plus 3 squared plus y minus 4 squared equals 25. Then let's try to FOIL this thing, or simplify it further and FOIL it. So you actually going to have something like x squared plus 6x plus 9, and here you're going to have y squared minus 8y plus 16 equals 25. Okay, then we have x squared plus 6x plus 9 plus 16, they're going to give us 25, plus y squared minus 8y equals 25. Okay, therefore x squared plus 6x plus y squared minus 8y. Then we do what? We take the 25 and transpose it to the left. It will be 25 minus 25. So even if I can write 0 here, because they're going to cancel out and give us the difference of 0. Then we actually proven it that x squared plus 6x plus y squared minus 8y, it is the equation of the circle. So I'm not sure if you understand what I just did here. So this is how you do it. This is how you're doing it. Okay, let's try to do this. Consider the circle with the center. Then this is the equation of the other circle. They want us to determine whether the two circles will intersect, touch, or not at all. So this is these two circles we need to actually work out and come with the conclusion that they are intersecting or touching or not at all. So we're going to use the centers. So we have negative 3 is to positive 4 of the first circle, and the second one we have positive 4 is to negative 4. Then we're going to find or determine the distance using these two centers. Then r squared here equals 25. You square root both sides. Okay, you square root both sides here so that you can find the value of r. So r equals 5 units. And as you can see here, we also have 5 on the other circle or equation. So they have equal radius or radii. Okay, so we can find the distance using these 2 points. So x1 is negative 3 minus 4 squared plus 4 minus 4 close bracket and close bracket squared. So I do not have a calculator with me here, so we'll do it manually. Therefore distance equal to inside the first bracket we're going to have 49, because negative 7 squared is going to be 49, then plus 4 negative into negative 4, it's going to give us positive 8. Therefore 8 squared is 64. I do not have a calculator here with me, so we'll do it like this. 9 plus 4, that's 13, carry 1. 6 plus 4, it's 10, plus that 1, it is 11. So the distance here is square root 113. Then if you write it in decimal, it will be, okay, let me use the calculator from my phone to write it in decimal form. But we'll confirm if this square root 113 is correct. And with my calculator here on the phone, I'm not sure if this calculator is accurate, I don't trust it, but it says it is 10.63 units. So for us to find or for us to conclude saying that the circles are intersecting or touching or not at all. Okay, first let me actually make a space here by removing the calculations that I was doing here. Okay, we have the distance. Now we must calculate we must actually sum the radii. So R1 plus R2, 5 plus 5 equals 10 units. But you can see when you compare the distance and the radius that the distance is greater. Distance is greater than R1 plus R2. Therefore, we can go back to what I was explaining on this video. What is the meaning when we have D greater than R1 plus R2? Are the two circles intersecting by having that, or touching, or not at all? Now we know that the two circles do not touch at all. Why? Because the distance of the circles is greater than the sum of their radii. I hope you understand that, guys. So it is very, very important. Very, very important. So now I want to give you one question just to challenge you and leave your answer on the comment section, please, guys, so that I can see that what I'm doing here, you actually getting the gist of it. Yes, so leave your answer on the comment section of what I'm going to give you now as the question that you can try to attempt. All right, let me clear everything so that I can have a space. Okay, B, they say find the equation of VR. Remember, VR is the tangent, meaning find the equation of the tangent. So use the knowledge that you have so far to find the equation of the tangent. And remember, you do have B as the center. And you must have what? L as the point of contact. Find L first so that you can find the equation of the tangent. So thank you, guys. Please do not forget to like the video and subscribe. Thank you.